Hey class, Mr. Mohidian here with another mixed bag of derivative problems to help you out with, in addition to the practice test. So here we have the derivative, we're asked to find the derivative of secant of 4x squared minus 2. So secant of x is just secant x tan x. So we know in the shrub here of thought that, okay, so derivative, oops, don't need the y there, derivative of secant is secant of x is secant x tan x, but this is not just plain old x, but you know, we can at least start it that way. So since the inner part, which I'm going to color blue here, has its own derivative, it's a pretty party hopping place there. It has its own derivative, so we're going to need the chain rule at some point. But until then, secant of the blue, its derivative is just going to be secant blue tangent of whatever the blue stuff is, right? So 4x squared minus 2 and 4x squared minus 2. And it'd be nice if life were this simple, but we know from the chain rule that it's a little more complicated because the party that's raging in here is going to be chained on the outside the after party. So 4x squared minus 2, its derivative is 8x. So the final answer, to simplify this, conventional wisdom has the trig stuff put at the end for some reason. So 8x times secant of 4x squared minus 2 tangent of, whoops, didn't mean to have that parentheses there, tangent of 4x squared minus 2. Not very pretty, but the answer nonetheless. Another example here. Tangent squared 5x minus 2. You might think, all right, not too bad. But beware, this is quite a tricky problem. So it might help to rewrite this as tangent of 5x minus 2 quantity squared. So right off the bat, once it's written in this form, you should realize that this is no ordinary problem. You have three functions going on here. You have some math junk that's squared, you have tangent of something, and then you have 5 somethings minus 2, or 5x minus 2. So quite a multicolored, complex problem there. But we can handle it with the chain rule, because the chain rule is, as we've seen, quite powerful. So the derivative of this function, we're going to start at the outside, because as we saw from the verbal interpretation of the chain rule, it's the derivative of the outside evaluated at the inside. So the outermost function is the green one, so that's going to be 2, so that's something squared. The green stuff, whatever it's inside, squared. So it's 2 times whatever that is to the first power. So whatever that is happens to be tangent of 5x minus 2. So that'll stay untouched. Pretty party-like atmosphere in there. That's okay. We'll deal with it in the appropriate time. So tangent of 5x minus 1. Oh, sorry, minus 2. Don't know how that happens. Minus 2. Trying to keep it color-coded for you. So green thing squared, the derivative is 2, whatever's in the green part to the first power, but that green part, the inside part, has its own derivative, so the party is going to spill over to the after party. So tangent of something is going to be, its derivative is, well, famously secant squared of something. So that's going to spill over, and we have 5x minus 2 still raging in there. But as you know from the song After the After Party, it's the hotel lobby. So we're going to chain on a second chain, or 2 chains, trademark, in this problem. So 2 was the outside squared. It was squared, now it's 2 math to the first power. Inside part's derivative is secant squared of the blue stuff. The blue stuff's derivative spills out a 5. So 3 functions here, red, blue, and green, and 2 chains as a result. So y prime would be, well, we can simplify 2 and 5, giving us 10. And let's see, it's 10, not 1.0, 10. Let's see, we have tangent 5x minus 2 and secant squared 5x minus 2. So pretty complicated looking answer, but it's also a complicated looking problem at the beginning. Alrighty, hope this helps.